Hello, chemistry students. Welcome to your next installment of the types of chemical reactions. Today we are focusing on decomposition reactions. We're going to start with the definition of a decomposition reaction. The definition of a decomposition reaction: a single compound is broken down into two or more products. So a decomposition reaction, we have a single compound. It is going to be broken down into two or more products. Again, just like we'll do for all of the 5 types of chemical reactions, we're going to start by talking about reactants. We want to talk about how many there are and what types they are. So starting with our reactants, if we look at our definition, we should be able to tell how many reactants we're going to have. So in a decomposition, there's always only one. Okay, so we always only have one reactant, and it is always a compound. Okay, so for a decomposition reaction, we're always going to only have one reactant, and it will always be a compound. For our products, it's going to be more than one. Okay, usually two elements. Okay. But it doesn't have to be 2 elements, okay? It could be 2 compounds if it was a particularly big compound to begin with. Or it could be 1 element and 1 compound. And again, because of this variability in what the products can be, it does make it so that it is difficult for kind of starting out chemistry students to predict what the product of a decomposition reaction will be. Okay, so a decomposition reaction, a single compound is broken down into 2 or more products. In terms of the reactants, we always only have one reactant, and it's always a compound. In terms of products, we're always going to have more than one, so we'll have 2 or more products, and those products can be 2 elements, they could be 2 compounds, they could even be an element or a compound, and a compound. And because of that variability in the products, it is hard to predict the products of decomposition reactions. Now, for things to decompose, okay, typically you're going to need something for that to happen. So decomposition reactions usually require some form of energy to take place. Like heat, light, or electricity. Springtime is kind of a time when we're familiar with this. We often see, because of where we live, roadkill, right? Dead deer, dead animals that over the winter got hit by a car. And in the winter, when it's cold and they're frozen, they don't do any decomposing. But in the springtime, on those couple first nice warm spring days, and you're riding around in your car and you want to have your windows down, you will know when you're near some roadkill because there's quite an odor. And again, that's happening because now there's that source of energy that's allowing that roadkill to decompose. That heat, that light are decomposing that. So typically when you have a decomposition reaction, there's going to be some sort of form of energy necessary for that decomposition reaction to take place. Often it's going to be heat, light, or electricity. So our example decomposition reaction we're going to look at, again, we want to remember the steps that we're going to follow to write a balanced chemical equation. So again, I've given you a sentence. Sometimes your textbook, it's going to be more like a paragraph, okay? The first thing we're going to do with that sentence is we're going to make it a word equation. Remember that our only symbols in a word equation are plus signs and arrows. The purpose of that word equation is to get rid of extra information that we don't need, okay, and to leave it out so that we really can just focus on what's important. Once we have our word equation, the next thing we're going to do is write a skeleton equation. The difference between the word equation and skeleton equation. The word equation has words in it. The skeleton equation, all of those words, so those elements and those compounds have become chemical formulas. So in our skeleton equation, everything's a chemical formula. We have to be careful. We have to make sure our chemical formulas are written correctly for molecular and ionic compounds. Because once we have our skeleton equation, we can't change any of our subscripts. That would be changing what compound do we have. So to balance, remember our skeleton equation, we're going to use coefficients. Coefficients go in front of our chemical formulas so that we make our equation follow the law of conservation of mass, which says the mass of our reactants has to equal the mass of our products. We're not going to do that with mass. We're going to make sure that we have the same numbers of atoms on both the reactants and the product side of the equation. So our decomposition example is calcium carbonate is heated to produce calcium oxide and carbon dioxide. So our word equation is going to be calcium carbonate now, again, is heated to produce, right? That's going to become my arrow. And again, you can indicate that heat with that little triangle that means heat. You also could use the word heat. Again, that's not super important to me, but we'll go ahead and put it in there. And then we have calcium oxide plus carbon dioxide. Because again, remember our and becomes a plus sign. So now we have our word equation. Now we're going to start our skeleton equation. So we start with calcium carbonate. That's a compound. Is it an ionic or a molecular compound? It is an ionic compound. One of the ways we know is that calcium is a metal. The other way we know is, remember, carbonate is one of our 10 polyatomic ions we have memorized. So remember the steps to write the formula for an ionic compound. Symbols, charges, crisscross, lowest whole number ratio. So our symbol for calcium is Ca. Its charge is +2 because it's in group 2A of the periodic table. Carbonate that you have memorized is CO3 with the charge of -2. So I could crisscross down those 2's, but remember then I would have to reduce them because I'd have 2 and 2. So the lowest whole number ratio will just be a 1-to-1 ratio there. All right, so next we have calcium oxide. Again, that's a compound, so the question is this ionic or molecular? It is an ionic compound because calcium's a metal. So again, we're going to do symbols, charges, crisscross, lowest whole number ratio. Our symbol for calcium is still Ca, and its charge doesn't change. It's still +2 because it's in group 2A. Oxide is O with a charge of -2. So again, I could crisscross down those 2's, but I'm going to end up reducing them to 1-to-1. All right, carbon dioxide. Again, that's a compound. Is it ionic or molecular? It's molecular because it's 2 nonmetals. So remember, for molecular compounds, prefixes become subscripts. And when there's no prefix on the first element, it's a 1. So our formula for carbon dioxide is C, O, and then a 2 because it's dioxide. So now we have our skeleton equation. Now it's time to balance this. So again, I have 1 calcium here and I have 1 calcium here, so that looks fine. I have 1 carbon and I have 1 carbon, so that looks fine. I have 3 oxygen and I have 2 plus 1 more makes 3 oxygen. So this happens to be a skeleton equation that is also a balanced chemical equation. Again, to kind of review, one of the things that you will have to do, okay, by the time we get to the end of this chapter, is given a whole bunch of chemical reactions, identify them as to type. So we've already talked about combination reactions. Remember, how are we going to know that a reaction is a combination reaction? For a combination reaction, we're going to have 2 reactants and a single product. Today we talked about decomposition reactions. If we're looking at that big list of chemical reactions, how will we identify which ones are decomposition reactions? Yes, decomposition reactions are going to have a single reactant and multiple products. So your homework for tomorrow is to do the word equations worksheet. A blank copy of that word equations worksheet will be available in Google Classroom. It will be in the assignment as well as in the stream. Thank you. Have a good day.